Hello, in this video we will go over set theory, one of the important topics discussed in 7th grade or class 7 of your school math program. Alright, so with that said, let's get started. What is a set? So set is nothing but a collection of distinct objects of the same type. The thing is that it's denoted by curly braces as shown here. For example, I have a set A which consists of a finite set of 5 elements, 1, 2, 3, 4, and 5, the natural numbers. The way you denote that a particular element of the set is denoted by the Greek letter epsilon. The other, for example, the number 6 is not an element of A. It's nothing but a strike over the epsilon notation for when an element is not part of the set. Okay. A few properties associated with sets. A set can be finite or infinite. An example of an infinite set, is the set of natural numbers, right? Because you start with 1, 2, 3 all the way up to infinity. So another example is a set of real numbers. That's an infinite set as well. Finite set, of course you can count the number of elements in it. That's a finite set. All the elements of a set are unique. They have to be distinct, and it must be, should all be the same type. An empty set is nothing but a set with 0 elements in it, and it's notated by the open and closed curly braces as well as the 0 notation here, that it is a variant of 0 and it's not related to the Greek letter phi. The number of elements in a set is called the cardinality of a set. For example, as we saw previously, the cardinality of A would be 5, and it's denoted by this. So getting more into the details, let's look at what is a union, an intersection, a complement, and a universal set. So first off, in this example we have two sets here. Set A consists of the numbers 1, 2, 3, 4, and 5, and set B consists of 4, 5, 6, 7. There are two numbers here, 8 and 9, which are neither in A nor in B. So the union of A and B is determined by all the elements of A as well as all the elements of B. So the union, which is denoted by the symbol here, it's of course all the numbers, elements in A and all the elements in B. So it's 1, 2, 3, 4, 5, 6, 7. Since they are supposed to, since a set is distinct, consists of distinct elements, we do not repeat 4 and 5 even though they fall in both A and B. Now what is the intersection of A and B? The intersection of A and B, denoted by an inverted U, is the elements which are common to both A and B. In this example it's 4 and 5. So that's the intersection of A. Now what's a complement? Now complement is denoted by this symbol A bar, and it is all the elements that are not in A. So all the elements not in A are 6, 7, 8, 9. Please note you also include the elements 8, 9, as I'll come back to that when I discuss universal set right now. So looking at a universal set is nothing but all the elements that we're looking at. So not just the elements in the set A, B, but also the elements outside of A and B. So the universe in this case consists of 1, 2, 3, 4, 5, 6, 7 as well as 8, 9. So A bar is all the elements within the universe here that are not in the set A. That is why we get 6, 7, 8, and 9. They are all within the universe, but they are not in the set A. Hope that was clear enough. Important topic to discuss is subsets. Let's take a look at this example here, right? We have three sets. Set A consists of 1, 2, 3. Set C consists of number 7, and set B consists of 1, 2, 3, 4, 5, 6, and 7. So in this case, A, the subset is denoted by this notation, horizontal U with a bar under it, and a set A is a subset of B when the intersection of the two sets equals A, as well as the cardinality of the intersection is A. So in this example, the intersection of A and B is nothing but the set A, as well as the cardinality of the intersection is also A. So that qualifies set A to be a subset of B. In a similar fashion, set C, which consists of the number 7, is also a subset of B because every element of C is in B, and the cardinality of the intersection of C and B, which is nothing but the number 7, is also the set C. And that's how we determine if it is a subset of another. Another variation of a subset is what is called a proper subset or a strict subset. It is denoted by this notation here, horizontal U, if you would, with no bar sign. So what is a proper subset? A proper subset is when every element of A is in B, but there are some elements of B, like these 4, 5, 6, 7, which are not in A. So there should be at least one element in B which is not in A, and that's when it becomes a proper subset of B. Alright, that was exhaustive enough. Hope you enjoyed this particular video. If you did, please give your thumbs up as well as subscribe to our channel. Looking forward to talking to you all soon. Thank you so much. Bye bye.